Let's discuss chapter number 15, the electromagnetic spectrum. The electromagnetic spectrum is a continuous range of waves arranged in order of wavelength or frequency, as you can see over here in this diagram. Longer wavelength, lower frequency; shorter wavelength, higher frequency. From longest wavelength to shortest, the main regions are radio waves, these ones, microwaves, these ones, infrared, these ones. Similarly, we have visible light, red, orange, yellow, green, blue, indigo, violet. Then we have ultraviolet, these ones. Then we have X rays and gamma rays, which is these. Visible light is just a small part of the full electromagnetic spectrum. Let's discuss the properties of electromagnetic waves. All electromagnetic waves travel at the same speed in a vacuum. They are transfer waves. Transfer energy from a source to an absorber. Speed of electromagnetic waves. In a vacuum, electromagnetic waves travel at this speed 3.0 times 10 power 8 meter per second. This is approximately the same as their speed in air. A useful way to remember the order is to create a sentence. For example, ragging Martians invaded Venus using X ray guns. So, radio, M for microwave, infrared, then visible, ultraviolet, X rays, and gamma rays. Alright, also helpful: radio waves, longest wavelength, and gamma rays, shortest wavelength. Use of electromagnetic waves. Different parts of a spectrum have different common uses. Radio waves, radio and TV broadcasting, radio astronomy, RFID, radio frequency identification, example, contactless cards tags. Microwave, satellite TV, mobile phone communication, and microwave ovens. Infrared is used in electric grills and heaters, TV remote controls, burglar intruder alarms, thermal imaging cameras, transmission in some optical fiber system. Visible light is in human vision, photography, and video cameras, lighting and illumination. Ultraviolet rays are used in security marks that glow under UV, checking for fake banknotes, sterilizing water by killing microorganisms. X rays, medical imaging of bones and internal structure. Security scanners in airport and other buildings. Gamma rays used in sterilizing food, sterilizing medical instruments, detecting cancer, treating cancer, radiotherapy by killing cancer cells. Many everyday things such as Wi Fi, radar, mobile networks, and satellite links actually use microwaves, not radio waves. Infrared emitted by warm objects, detected using thermal cameras in security, research, and medicine. Used in remote control, small infrared LEDs send signals to receiver, often used instead of visible light in fiber optics because it travels with lower loss in glass. Ultraviolet, causing tanning as the skin reacts to UV to protect itself. Certain material absorb UV and re-emit visible light. This is called fluorescence. Fluorescent inks can be used for hidden security markings on money. Fluorescent lamps also use UV and fluorescence to produce visible light. X-rays pass through soft tissues but are absorbed by denser material like bone, used in X-ray images that show bones and some internal damage. Let's talk about gamma rays, kill cells and microorganisms, used to destroy cancer cells in targeted radiotherapy, used to sterilize food and medical tools by killing bacteria and other organisms. Dangers of electromagnetic waves. Too much exposure to electromagnetic radiation can be harmful. As you move up the spectrum in frequency towards UV, X ray, gamma, the waves carry more energy. Beyond visible light, the energy is high enough to ionize atoms, so ultraviolet, X rays, and gamma rays are called ionizing radiation. Higher frequency, more ionizing, more potential biological damage. Some typical risk: radio waves, no proven harmful effects at normal exposure levels. Microwaves can cause internal heating of body tissues if they are intense. Infrared can cause skin burns and high exposure. Ultraviolet can damage surface cells and eyes, increases risk of skin cancer, can cause eye problems such as cataracts. X rays and gamma rays can damage or mutate DNA, increase the risk of cancer. Microwave danger. Certain microwave frequencies are absorbed strongly by water molecule. Because the human body contains lot of water, intense microwave can cause heating of tissue. Communication microwave, phone, Wi-Fi are low power and have not been shown to cause harm. Microwave ovens use high power, but the metal walls and mesh in the door stop the radiation from escaping. Ultraviolet dangers. UV carries more energy than visible light, can damage the retina if it enters the eyes in high amount. Good sunglasses block UV to protect the eyes, can damage or kill skin cells and cause them to grow abnormally, skin cancer. Sun screens absorb UV and help protect the skin. X rays and gamma rays danger. Highly ionizing, can penetrate the body and damage internal cell, can cause mutation in DNA and lead to cancer. Communication, satellite communication. Microwaves are used to communicate with artificial satellites. Some satellite phones use satellites in low orbits. Other systems, satellite TVs, some satellite phones use geostationary satellites. Low Earth orbit satellites orbit much close to Earth around 200 km above the surface, often used for weather observation, military imaging, and mapping. Signals have less delay and clearer image because of short distance. Many satellites are needed for continuous coverage. Polar orbit satellites are a type of low orbit satellites that pass over the poles on as Earth rotates. Geostationary satellites orbit above the equator, have an orbital period of 24 hours, stay above the same point on Earth's surface, orbit at about 36,000 kilometers altitude, used for global broadcasting of TV and telecommunication signals. Communication system. Many communication systems rely on long wavelength electromagnetic waves. Microwaves, mobile phone, satellite TV, wireless internet. Radio waves, Bluetooth, terrestrial TV signals, local radio stations, visible infrared, optical fiber for high speed data, and cable TV. Microwave used to transmit signals over long distances. On Earth, mobile network use masts that send a microwave signal to each other and to phones. Mast must be placed so that obstacle hills, Earth's curvature do not block or defract the beam too much. Microwave are not significantly absorbed, reflected, or refracted by the atmosphere or ionospheres. Suitable for satellite links around the planet, can pass through many walls and need only small areas on devices. Radio waves used for shorter distance transmission. Typical wavelength can be around a kilometer, can diffract band around hills because their wavelength are similar to the size of the obstacle. Bluetooth uses short range radio waves to connect devices like phones, speakers, and headphones. Bluetooth uses shorter wavelength than broadcast radio or TV, so it can carry high data rates but only over relatively short distances. Signals can still pass through walls but are weakened. Let's talk about optical fibers. Use visible light or short wavelength infrared. Used for cable TV and high speed broadband internet. Light or IR can carry large amount of data because of their high frequency. Light pulses travel inside the fiber by total internal reflection. Now let's talk about digital and analogous signals. Type of signals. There are two main type of signal. One is analog signal. Change continuously, can take any value within the range, look like small varying waveform. Digital signal only take a small number of discrete value, usually 2, often represented as 1 and 0, high and low, on and off. Digital signal example look like square wave switching clearly between two levels. Transmission of sound. Speech and music consist of many different frequencies combined together. To send these clearly, the signal must be transmitted within as little interference and noise as possible. In digital communication, the original analog signal, for example, from a microphone, is converted from analog to digital before transmission, sampling, transmitted in digital form, converted back from digital to analog at the receiver, so it can be heard again as sound. Now let's talk about digital sampling. Digital sampling means measuring the amplitude of the analog signal at regular time intervals, recording those measurements as numbers, digital values. Benefit of digital signals. Advantages of using digital over analog include data can be regenerated accurately at each stage, reducing noise and distortion. Signals can be transmitted over longer distances with better quality. Higher data transmission rates are possible. Extra bits error checking can be added to detect and correct error. Because digital signals only have two definite levels, 0 and 1, it is easier to clean up a weak or noisy signal back into a perfect digital form. With this, we have finished our this chapter. See you in our next chapter.